Welcome to our first video on Chapter 7. This video will be discussing random variables. So we have two types of random variables we're going to be talking about, discrete and continuous. The first type, discrete, is one that's countable. You can think of it like the integers or whole numbers. And then a continuous you can think of more as the real number system, where it takes on the irrational numbers, the rational numbers, the like things like pi or e, takes on all the values in between numbers. So that's continuous. You can't count those. So with discrete random variables, we can list that in a probability distribution table. And in this table, we can take all the values our random variable can take on and the probability of getting those values. There are two things this distribution must satisfy. The first is the probability of each random variable value occurring has to be between 0 and 1. And then the sum of all the probabilities for this distribution have to add up to 1, because you can't have more than 100% of your distribution, the probability being more than 100%. So let's take an example to make this more clear to you. All right, so for an example, let's say we're tossing a coin 4 times, and you might think to yourself, well, the outcomes are heads and tails. We can't do numbers for this. But as long as we assign something that we think of as a success to the random variables, we can change almost anything into a numeric value. So for this case, let's look at what's the probability of getting heads. So if we let x equal the number of heads we get when we flip a coin, then we have 5 possible outcomes. We could get 0 heads, 1, 2, 3, or 4 heads. So I'm going to make a table here where x is the number of heads, and then we have the probability of x. So we could have 0, we could have 0, 1, 2, 3, 4 heads. And you'll have to take my word for it right now, but these are the probabilities of each of these happening. We will learn an easy way to get these probabilities, but that's in the next chapter. However, you could probably figure these out with the basic probability that you do know. All right, so the probability of getting 0 heads is 0.0625. And then it goes on from there. If you are to add all of these up, you will see that all the probabilities add to 1. And then also you'll see none of the probabilities are less than 0 or greater than 1 by themselves. So this would be your probability distribution. All right, so how about you give this a try? So we have a university grade distribution for the courses online in statistics and how many got the different grades. And we want to choose a student at random and have the probability distribution so we can figure out some probabilities when we choose a student at random. We want to figure out what's the probability they got a B or better. And so if you are unsure with the grading system, an A is 4, B, C, D. I was going to go F, but that I was going to go E, but that's an F. All right. So I would pause this, and then when you press play, I will go to the next slide. All right, so here is the distribution of the different values, and if it's helpful, I will write the letter that goes with each. So we want the probability that a student got B or better. So since this is discrete and these are the only valid answers, the probability of a B or better is the same as a probability of 3 plus the probability of a 4. And so then we can just add those together and we get 0.64. So the probability of getting a B or better is 0.64. And just a note, in terms of notation, that probabilities are given as decimals, not percentages. So, and it is good to put the 0 in front just for readability. All right. Next, we have probability histograms, which is just a way to visualize the table. And these you do not, obviously this is not a probability histogram of the previous slide, as there are more than 0 to 4, there are those numbers up there, but it's just a histogram with the probabilities on the y-axis and the random variable values on the x-axis. They don't have to be touching, because sometimes your random variables, your discrete random variables aren't consecutive, so it's fine if you have gaps. All right. Then let's talk about a continuous random variable. So again, think of that like your real number system. If I'm taking on values from 0 to 1, then I could take on 0.3 repeating or 0.27. You could take on an infinite number of possibilities. One way to represent this is if you have a uniform distribution. So the area under the uniform distribution has to equal 1. So area under your curve has to equal 1. If it's uniform, that means all the values are equal. And to find the probability, you have to have a range of values. So just like in normal distribution, there's not a value at a point because you need the area under the curve. Same way here, there's not going to be a value just at 0.7. I need a range so I can get an area under the curve. Now you'll notice this is a 1 by 1. So obviously the area is 1 times 1. You get the total area is 1. If I wanted the probability between these, this is 0.4 times 1, so it would be 0.4. Now your uniform distribution doesn't have to have a height of 1. Let's say you're rolling a die, then your uniform distribution would have a 1 through 6 and would have a height of 1/6. Here is another example. Let's say we have a 1 through 5. So this is a 0. So this is a width of 4. So the height has to be 0.25. And because when I multiply these, I need to get an area of 1. And then I could find what's the probability of, let's say, x is less than or equal to 3. So then it's here. I want this area. So this has a length of 2, so this would be 0.5 because it'd be 2 times 0.25. All right, so then we don't have to have a uniform shape. You could have some random shape. And it's just the area, the probability of the event times the width and the height, you get the area. The most common distribution is the normal distribution. And that is back in our chapter 2. So I'm going to have you quick pause for a second, see if you remember these questions. And once you've answered, press play again. All right, so mu is the mean. Sigma is the standard deviation. Which is how far on average are you away from the mean. And the z formula is x minus mu over sigma. And this notation right here is just shorthand for we got a normal curve, the mean is 0, standard deviation is 1. And then a couple reminders, normal CDF is the area under the normal curve that gives you your probabilities. Normal PDF we don't use because that's the value at a point, and like I was saying on the uniform curves, you can't get a value at the point because you need the area under the curve so you don't have a width. And inverse norm gives you the z value if area is known. So in other words, if you know the probability and you're trying to figure out what x value gives you that probability. So our last example in this section is using the normal curve. So let's say the probability a student will report another student cheating is 0.12. So this is based on a random survey of 400 people, and the average probability we got was 0.12 with a standard deviation of 0.016. You will learn more how to do these calculations to get that standard deviation later on. All right, so this is continuous because if you draw one sample of the 400, you'll get probably a different proportion than if you draw another sample. So you could get a continuous number of continuous answers. So we want to know what is the probability that if I conduct a survey, my results will differ from the true probability by more than 2%. Now, the other thing you have to be told at this point is that the distribution is approximately normal. Later on, you'll have a way to check this. So how you do this is if we're going to differ by more than 2%, if I drew the normal curve, and I had 0.12 is my mean, and 2% down would be 0.10, 2% up would be 0.14. We want to know these two values. Now you can see this is symmetric right now. So there are a few ways to figure this out in your calculator. But the first thing for either method is I would find the z-score. So if you find the z-score, let's say we just do the 0.1, so 0.1 minus 0.12 over 0.016. That gives you negative 1.25. If you do the other side, it's going to be symmetric because you're going plus or minus 0.2, so it's the same difference in the numerator. Now you'll notice in the work on the bottom I have here, I found the area in between. So I found this area. And this is one way to do it, is to find the area in between and then subtract from 1, and that'll give you the area I have shaded in red. Another way to do it, since this is symmetric, you could just find one of these tails and multiply the answer by 2. If it's not symmetric, you'd want to do each tail and then add them together. But there's a few ways to do this. So the probability ends up being 0.2112 or 21%. All right, so just a little preview of the next video. We're going to do means and variances of random variables. I will see you in that video.